So what is the relationship between eye movements and film comprehension so far from previous research that we know of? There's not very much. But we do know that movie viewers show strong attentional synchrony. Attentional synchrony is basically this. So here's a still from, does anybody know what movie this came from?
Blade Runner.
Blade Runner, very good. Yeah, so this is from Blade Runner. It's one still, and at this moment, each of these circles is a different person's eye fixation. Okay, and what we see is all these different people are all looking at more or less the same place. And because this is a still, that is one point in time. So all these people are looking mostly at the same place at the same time. That is what we call attentional synchrony. Okay? Synchrony is same time. So attention at the same time. Okay? All right. And so we have this attentional synchrony, and it has led us to what we are calling the tyranny of film. Okay, so what is the tyranny of film? Tyranny, by the way, is, let's see, asse, right. Okay, so eiga no asse. All right, the tyranny of film. But what is that really? Well, if everyone looks at the same places at the same time, okay, then there should be no chance to find differences in eye movements that are caused by differences in film comprehension. So if two people have two different understandings of the film, but they all look at the same places at the same time, then their eye movements are not going to show differences of understanding. Does that make sense? So that's what we're calling the tyranny of film. All right. Now, understanding a film requires us to interpret thousands of shots. So a typical movie these days has a new shot every 2 or 3 seconds. Okay? And if you have 60 seconds in a minute and 60 minutes in an hour and 2 hours for a movie, you end up with thousands of shots. Okay? So to understand the movie, you have to put all those shots together. And to create understanding across the shots, which we call coherence, that is to make sense across those shots, okay, we have to interpret the rules of film editing. Okay? So let me give you an example of that. I'm going to show you 6 shots from a James Bond movie called Moonraker. Okay. Okay, and having watched that, now I want you to tell me, what do you think will happen next? Anybody have an idea?
Well, the guy fell down on the tent.
Okay, the guy that we saw falling through the air will fall on the circus tent. How many of you think so? Most of you. And that's correct. That is the next thing that is shown in this film. Okay? All right. So what that means is you have a good understanding. Okay? You just watch a film clip. There was no words, no sound, and yet you were able to make a prediction that was correct. So your understanding is good. This is a very important point. And so that's called making an inference. You made an inference. You didn't have the information yet, but you were able to guess. You were able to predict what would happen next. Okay? All right. So we had 6 shots. Okay? In shots 1, 2, and 3, in shot 1, you see the guy pull his ripcord and it breaks, and his parachute does not come out, and he is in shock, and then he starts reacting to it. And then we have a very interesting thing in shot 4. Something different is happening. Okay? We have what's called a cross-cutting sequence. Okay? So all shots 1, 2, and 3 are the same guy. But now we see a circus tent. in shot 4. Very different. It's a very different place. Okay? But then in shot 5, we see the guy again. But then in shot 6, we see the inside of a circus tent. Okay? So we're going guy, circus tent, guy, circus tent. That's called cross-cutting. Okay? So this cross-cutting sequence creates a puzzle for the viewer, the movie viewer. They have to try to understand why are they being shown two different sets of things at different places. Okay? And this cross-cutting is a technique of film editing, and in it, the film editor is trying to show that these two things that are being cross-cut are going to come together in one place and one time. Not always, but oftentimes that's what happens. And so that helps us to make the inference that this guy who's falling through the air is probably going to fall on this circus tent. It'll come together at the same place and time. Okay. All right, and so at the end of showing this, then we ask people what will happen next. And just like you guys, most people think that Jaws, or the guy, will fall in the circus tent. And that was shown in a study by Joe Magliano back in 1996. And so, based on this, that was a very nice example of drawing a predictive inference. Because people will do it, almost everybody will do it, okay? And it's an inference, and it shows comprehension. So we decided to do a study with it. And so this is our case study number 1, experimental case study, I should say, using the James Bond Moonraker clip. And it's reported in this paper. And we thought that it's a case study because we only have one film clip, so it's a case study. But it was an ideal film clip for our purposes because it's a Hollywood movie, and so it should produce very strong attentional synchrony. Okay? And we know, based on Joe Magliano's research, that there's this predictive inference that people need to make. What's going to happen next? That the guy's going to fall in the circus tent. And it requires higher level comprehension processes. Okay? So it's not simple comprehension to actually predict what's going to happen before you see it. So in our experiment, we used a new method that we created, and we called it the jumped in the middle paradigm. The jumped in the middle paradigm is like when you're at home and let's say your friend or family member is sitting on the couch watching a TV show or a movie. And then you come in and you sit down next to them and you start watching the movie with them. Okay? But they watched it from the beginning. You jumped into the movie in the middle. Okay? So when you and your friend are both sitting there watching the same thing on the screen at the same time, your understandings will be very different. Your friend will have a much better understanding than you because your friend was watching it from the beginning. So this is how we could manipulate understanding, even though it's exactly the same thing. Even though they're watching exactly the same thing at exactly the same time. Okay? So we had two groups. We call the no context group. They only watched those 12 seconds I just showed you. Okay? And then the context group started watching it earlier. They watched the preceding 3 minutes and 8 seconds of the movie. Okay? So they had more context. All right? And so what we're doing is we're manipulating the event model. The event model is your understanding of what is happening now. Okay? But we're leaving the stimulus, that's the movie clip, exactly the same. Okay? All right. So in that paper that's right here, we had 3 experiments using this jumped in the middle paradigm or method. Okay? In experiment 1, we showed people the movie clips, the context and no context, and then after every shot, we stopped the movie and we gave them a text box, and they had to write their understanding of the story at that moment. Okay, so we call this Think-aloud. In experiment 2, we had event segmentation. So we showed them the video clips, and then either context or no context. We said, press a button anytime you think something new happened. So that's called event segmentation. And then if we look at the results from experiments 1 and 2, what we found was that the context condition had much better understanding. Okay? And so number one, there was a big difference. The people in the context condition were about twice as likely to predict that the guy would fall in the circus tent. Okay? So that's the key inference. And they were more likely to perceive coherence across the cross-cutting theme. To them, the cross-cutting between the guy falling and the circus tent made sense. But to the people in the no context condition, it didn't make as much sense. They were wondering, why am I seeing a circus tent? Okay. Then in experiment 3, we measured the eye movements. Okay.